We're going to finish up finding limits using tables and graphs. Yesterday we used tables, so guess what we're going to do today? Graphs, you're right. Excellent. There are a couple of things that are kind of interesting. A couple of things that are interesting with making graphs on your calculator that I want to show you as well. So I'll do that kind of as we go through. All right. All right, so deep breath, here we go. I don't think this lesson will take as long as yesterday took. Just because I don't think it will. So one of the things that can happen, we could have a piecewise defined function. So this function, as long as we're not 2, is going to follow the 3x minus 2 behavior, the linear behavior. But if it's equal to 2, if x is equal to 2, then our function gives us a value of 3. So we have that point, and then the graph I think I did that right. No, I did not. Yeah, I did. I shouldn't argue with myself. All right, so the graph that's really bad. It looks something like that. It's off a little bit down here. So if you remember from yesterday, we really don't care what happens when x is 2. We just want to know, as we get closer and closer to 2, what value do we approach? And for graphs, I like to use the finger method. So I just take a finger and put it on either side of the x value that I want, and I follow to where that x value is. I don't care if there's a hole there, but if my fingers come together, the y value where they come together is my limit. So this one, the y value, is 1, 2, 3, 4. The limit is 4. The function value is actually 3, but the limit is 4 because that's where my fingers come together. And you'll see if my fingers don't come together, then I just say the limit does not exist. So in this case, the limit as x approaches 2 is 4, even though f of 2 is actually equal to 3. So the limit does not have to always equal the function value. Usually it does, but it doesn't have to. If you wanted to graph this on your graphing calculator, and I have to see if I can make this happen. If I can, I'll be happy. So we would put in parentheses, and this is actually in the textbook, 3x, not negative, minus 2. X not equal to 2, right? X, and you go second math, and we want option 2, x not equal to 2 plus 3 if x is equal to 2. I don't think this is right. Something tells me it's wrong. Okay, yeah, it doesn't. All right, I will look though, but there is a way. I think, now that I think about it, I think we'd have to do this as 2. It might be like this. And then 3 if x is equal to 2. Nope. All right. Sorry. Okay. I should have looked it up before. But you could even, I know there's this new crazy thing called Google, and you could Google it on the internet and find out. I'll look too, and if I find it before the end of the hour, I'll yell at you, hey, this is how you do it. Actually, I think I can do it without looking it up on the internet. All right, another one. So here, we want the limit Sx approaches 0, and our function is x when x is less than or equal to 0, and 1 if x is greater than 0. So graphing this, at 0, 1, I would put an open circle because that's not, it's not 1 when x is 0. It's whatever value x is. And then it's 1 everywhere else. And so my graph would look something like that. So it's x when x is less than 0, so that would be a line with a slope of 1, intercept of 0, and it's 1 when we're greater than 0. And if I wanted to find the limit as x approaches 0, again, if I use my fingers and trace, there we go. Uh-oh, my fingers don't meet up. That means the limit does not exist. We don't approach a single value as our x approaches 0. So in that case, what we would say, a couple of ways you can write it. The way that I usually write it, the limit as x approaches 0 for f of x does not exist. So I just write DNE. as an abbreviated way of saying does not exist. The last example they had in the book, I found interesting, but kind of disappointing, the way that they solved it. So they have this expression, and they say, find the limit. And it says, using a graphing utility to find the limit. So to me, that says, we're going to graph it, right? No, they use the table of values. I'll show you, you can do this on the graph, and I will show you that because I think it's pretty, it's easy to see. It just surprises me that they would do that. Maybe I shouldn't be surprised with what textbooks do anymore. So I will leave this up like that, and then I'm gonna put it into my calculator as you're writing it down and maybe putting it into your calculators. So in your calculator, you would want to put the numerator in parentheses and the denominator in parentheses. Otherwise, your calculator is going to scream at you. Actually, it won't. It just won't give you the right graph. All right. So if I look at the graph, so you'll have to trust me that that's got everything in it. And maybe when I graph it, you can say, yeah, that's what mine looked like, or no, that's not anything that mine looked like. Yep, close, good, okay. So a couple of things you could do. You know, it pretty much, I think we can agree that as I approach 2, I'm going to come to this value right here, which is right about 1, maybe a little less than 1. Your calculator has this great feature called trace. And if I press trace and then enter my x value, so it's as x approaches 2. Oh, and it's undefined. That's why they did it that way. Okay. That's okay. Now you can use your arrow keys. Unfortunately, with the arrow keys, they don't allow to get real close. So again, I know I want to be close to 2, so 1.99999. And if we round a couple decimal places, maybe 0.889 looks like there. And if I go 2.00001, 0.889 there as well, okay? Again, you could use the table. That's another option. I don't think on a test or a quiz, I would ever say, nope, you have to do this one by a table and you have to do this one by a graph. I might ask you to graph it. I wouldn't ask you to graph this one, but I might ask you to graph the function, but not necessarily having to use the function to determine the limit. So that one, again, from the calculator. The limit as x approaches 2 of that, I'll write it out. It's a nice thing, if they call it f of x, then you just write f of x there, you don't write out the function. Is about 889. All right, so some homework and time to work. Yes. So 17 through 22, they give you the graph. So all you're doing is finding the limit. You can use the finger method if that works for you. And then 35 to 38 are those piecewise defined functions, and they say graph it and then find the indicated limit if it exists. If it doesn't exist, we just write DNE, does not exist.